In this lesson, we are going to look at perfect squares. In previous math classes, you would have looked at perfect squares of whole numbers. We are actually going to look at perfect squares of rational numbers. Before we get into the rational numbers though, let's understand or refresh our memories on what a perfect square is. Any whole number that can be represented as the area of a square with a whole number side length is a perfect square. The side length of the square is called the square root of the area. Now let's see what that means. So if we have a square, and a square is a four-sided figure with all sides equal and 90-degree angles. So all sides are the same, and that's what these tick marks here indicate. It means they're all the same length, and they all happen to be 5 units. So the area is 25 square units. We could actually have made this into a grid and shown that. So we would have had side lengths of 5 going in both directions. And then we could actually physically count how many squares are inside this big one. And we would have seen we've got 1, 2, 3, 4, 5, 6, all the way up to there are 25 squares there. So what we have, we know that the side length of the square is 5 and the area is 25. We can relate that to a square root and a perfect square. And we write it this way. We write the area inside the square root sign. We write the side length as the answer. So 25 is called a perfect square. We can make a perfect square that has 25 units in it. And when we do that, its square root is 5 because the side length is 5. So what we want to do is we want to look at the area of each square in the table, and we want to write the area as a product. And then we want to write the side length as a square root. So 49, if we write this as the area as a product, and we want to have the same number multiplied twice, because we want side times side of a square. So if we think about it, 49 is the same as saying 7 times 7. So if we're writing this as a perfect square in a side length, we would say the square root of 49 is 7. When we have 49 over 100, you look at the numerator and the denominator separately. 7 times 7 gives us 49. 10 times 10 gives us 100. So 7 over 10 times 7 over 10 gives us 49 over 100. Written as a square root, the square root of 49 over 100 is 7 over 10. So what we can see is when you have a square root of a fraction, you simply find the square root of the numerator and then the square root of the denominator, and you have your answer. 64 is 8 times 8. So the square root of 64 is 8. 64 over 100. So we would have 8 tenths times 8 tenths, because 8 times 8 is 64, and 10 times 10 is 100. So the square root of 64 over 100 is 8 over 10. 121, that's 11 times 11. So the square root of 121 is 11. Same thing if it's over 100. 11 over 10 times 11 over 10. So the square root of 121 over 100 is 11 over 10. Square root of 121 is 11. Square root of 100 is 10. 144 is 12 times 12. So the square root of 144 is 12. 144 over 100, so it would be 12 over 10 times 12 over 10. So therefore, the square root of 144 over 100 is 12 over 10. Square root of 144 is 12. Square root of 100 is 10. So the idea when we get to fractions is the same as if we had whole numbers, except this time you break the fraction apart and you find the square root of the numerator, which is the top, and you find the square root of the denominator, which is the bottom. A fraction in simplest form is a perfect square if it can be written as a product of two equal fractions. right? So that's what we just finished doing. We were able to show that the square root of 64 over 100 is 8 over 10 because 8 over 10 times 8 over 10 equals 64 over 100. So we were able to write it as the product of two equal fractions. 8 over 10 and 8 over 10 are equal. When a decimal can be written as a fraction that is a perfect square, then the decimal is also a perfect square. So if you have a decimal and you change it back into a fraction and that fraction is a perfect square, then the decimal also was. However, the other way of looking at it is if you find the square root of the decimal value, it either terminates or repeats. Terminates means it's got an end, and repeat is a pattern that never ends. It could be 2, 3, 2, 3, 2, 3, etc. Those would be repeating decimals. Determine the value of each square root. All right, so keeping in mind what it means to be a square root. The square root, if you multiplied the square root by itself, you would therefore get back what we were looking at. So we're looking for two numbers that are the same that multiply to give us decimal 3/6. So some of you may know this in your head, or you can use the square root function on your calculator. We're going to get 0.6. And we know this is true because decimal 6 times decimal 6 is equal to decimal 3/6. So this is our check. When we're looking at the square root of decimal 49. So can you think of a number that multiplies by itself to give you decimal 49? 49 is 7 times 7. So 0.7 times 0.7 gives us decimal 49. If you don't know that in your head, you can use your calculator and the square root function. So to check this, decimal 7 times decimal 7 equals decimal 49. So it works. Decimal 81. Can you think of a number that multiplies by itself to give you decimal 81? If you think of what you know in the whole numbers, 9 times 9 is 81. So decimal 9 times decimal 9 gives us a decimal 81. And again, use your calculator if you are unsure of that, and find the square root of decimal 81. But we know this is true. Can you think of one for the square root of decimal 16? Again, 4 times 4 is 16, so it likely follows the same pattern and makes sense that decimal 4 would be the square root. We can check it. 0.4 times 0.4 is 0.16. So we have done those correctly. We want to find the value of each of these square roots. And what I often see students do is they'll change the fractions into decimals and then find the square roots. We don't need to do that. In fact, most of these here, or all of these here, hopefully we could do them in our heads without a calculator. If you can't and you need to use a calculator, that is fine. But if you're changing them to a decimal, then you are going to likely need a calculator. If we can do these in our heads, we can probably do them without. So what we do here is we take that fraction and we think about it in two parts. Think about it as the square root of 1. What is a number that multiplies by itself to give you 1? Just the value of 1. 36. What is a number that multiplies by itself to give you 36? Maybe you're thinking of 6. 6 times 6 is 36. So the square root of 1 over 36 is 1 over 6. If you need to use your calculator, use your calculator twice. Find the square root of 1, and then find the square root of 36, and write those answers in fraction form. And we could check this. 1 over 6 times 1 over 6 equals 1 over 36. So we get our original square root value back. Looking at the second one, square root of 25 over 9. Look at the numerator, square root of 25. What multiplies by itself to give you 25? 5 does. 5 times 5 is 25. Look at the denominator. Square root of 9. What multiplies by itself to give you 9? 3 does. 3 times 3 is 9. Again, if you need to use your calculator, you're doing it twice. You're finding the square root of 25, then you're finding the square root of 9, and you're writing your answer as a fraction. Checking this, 5/3 times 5/3, 25/9. Looking at C. Square root of 64 is 8. 8 times 8 is 64. Square root of 100 is 10. 10 times 10 is 100. We can check this. 8/10 times 8/10 is 64 over 100. Let's look at the last one. Square root of 36. 6 times 6 is 36. Square root of 16, 4. 4 times 4 is 16. Let's do our check. 6/4 times 6/4. 6 times 6 is 36. 4 times 4 is 16. So if you can do these in your head, go for it. If you can't, use a calculator, but don't just change it to a decimal. Find the square root of the top and the square root of the bottom first. All right, let's look at the following. Is each fraction a perfect square? Explain your reasoning. So remember, in order to be a perfect square, we need to find two factors that multiply to the top and two factors that multiply to the bottom, of which they had to be equal. So let's look at 8 over 18. As it sits right now, can you think of two equal factors that multiply to 8? Not likely. Not whole number ones anyways. But one of the things you have to do is you need to look and see if you can write this in simpler form, because then maybe it will work. And what we know is we can take 2 out of both the top and the bottom, and we will be left with 4 over 9. Now ask yourself, are there two equal factors that multiply to 4? The answer is yes, 2 times 2. Are there two equal factors that multiply to 9? The answer is yes, 3 times 3. So therefore, 8/18 is actually a perfect square, because it can be simplified to 4/9, of which we can find two equal factors that multiply to give us 4/9. So yes, this is a perfect square. Let's look at 16 over 5. Can you think of two factors that multiply to give you 16? The answer is yes, 4 times 4. Can you think of two factors, equal factors, that multiply to give you 5? The answer is no. There isn't any. So therefore, we look, can 16 over 5 be simplified? The answer is no. There's no common factor that comes out of both of them. So since we can't simplify it, and we can't find two whole number factors to give us 5 that are equal, this is not a perfect square. So even though one part of it is a perfect square, the entire fraction is not, because in this case the denominator is not a perfect square value. So let's look at C. Can we think of two equal factors that multiply to give us 2? The answer is no. We could for the 9, 3 times 3, but there isn't anything for the 2. So therefore, and it's simplified, there's nothing you can remove from the 2 and the 9, this one is not a perfect square either. So you can answer questions like that, determining if they are perfect squares, by looking to see if you could actually take the square root of them. Is each decimal a perfect square? Well, with decimal values, we could change this back to a fraction and then go through the same process we just did. Or in this case, because it's already starting in decimal form, we can just take our calculators and we can find the square root of 6.25. And then we can analyze that value. So I'm going to take my calculator and I'm going to find the square root, and it's 2.5. A perfect square in decimal form, we talked about this briefly, needs to either terminate or repeat. Terminate means there is an end. And in this particular one, 2.5 is all that shows up on the calculator, so it is a terminating decimal. So therefore, this is a perfect square. And the reason is because it terminates. 2.5 times 2.5 is 6.25. It's not approximately 6.25, it is 6.25. Let's look at the next one, decimal 627. So again, because it's already in decimal form, we can just use our calculator for this. We could change it back to a fraction as well. And what I get is I get a number that fills up the screen on my calculator. So it fills up the screen. So what we can do is we can make an assumption. If it fills up your entire calculator screen, we can make an assumption that it actually continues. So we can say it's not a terminating decimal to our knowledge. All right? Potentially, maybe it terminates a couple decimals down. We don't know that. So if it fills up your calculator screen, let's make the assumption that it does continue. So we know it's not terminating. We have to look, is it repeating? There is no value here that ends up repeating over and over and never changes. Yes, there are 3 3s in there, but then there's a 1 and a 5. So there isn't a known repeating pattern here. So therefore, this is not a perfect square because it does not terminate or repeat. All right, last one. Calculate the number whose square root is the following. Now the values we're given here are the answers. They are the square roots. We want to find what the perfect square was. So these are the side lengths of some square. So remember, when we are finding the perfect square and we got our square root, to check, we took our square root, we multiplied it back by itself. So that's all we do here. This is the side length of our square. So to find the area or the perfect square value, we multiply each of these together. So we get 9 over 81. So what we are actually saying is the square root of 9 over 81 is 3/8. This is called the square root. And that's what we were given in the original question. We were given the square root. So we can do the same thing here, 1.8 times 1.8, and we will get our perfect square of 3.24. So what that says is that the square root of 3.24 is equal to 1.8.